All right, here we go, guys. Logarithms. Example 3, we're going to do all the examples on this slide. We're going to be asked to determine some logarithms within 4 decimal places. All right, now, just want to remind you that when you're trying to determine what a logarithm equals, the pattern that should come into mind for a question like this would be 2 raised to what power equals 64. Now, here on the first couple, I'll acknowledge to you these are kind of contrived, and I'm just trying to emphasize, reinforce how logarithms work. So one way you could do it would just be to guess, and you could start guessing and you go, well, I don't know, I'll make a list here. 2 to the first power is 2, 2 to the second power is 4. See, these numbers are too small. The target is 64. Just trying to help you remember how logarithms work. 2 to what power makes 64? Well, 2 to the third power is 8. That's smaller than 64. We need to bump the power up. 2 to the fourth power, 16. These numbers are getting bigger. They're getting closer to 64, but that's not it. Let's see, 2 to the fifth power. Well, 2 to the fifth power is 32. Now we're getting closer. 32 is still too small, isn't it? So wouldn't we need to try another power here? Let's try 2 to the sixth power. Calculator. 2 caret 6. Things like that. When you put 2 to the sixth power in there, you hopefully go, what? That's 64. 2 to what power equals 64? Oh my goodness, there it is. What power makes 64? Sixth power. Okay, see, that was kind of contrived. Now look, we want to get beyond making a list until we happen to maybe stumble on the answer. But I do that to hopefully reinforce to you that when you're calculating a logarithm, you're saying the base to what power makes the anti-log the 6 on this one. All right, now, I hope when we move to the next one, you probably know the answer to this one before the old man even has time to turn around. And I want that to be the case. But if somebody asked you, what's the log base 7 of 49, 7 to what power equals 49, I understand I don't want to do the list approach all the time for the rest of my life, but let's give it a shot anyway. 7 to what power makes 49? I'll start with 7 to the first power. That wasn't a very good guess, was it? All right, it's only 7. So I need a higher power, don't I? So I'll try 7 to the second power. What in the heck is 7 to the second power? Seven to the second power? Well, that's 49. Look at that. So should that logarithm equal 2? Because 7 to the 2th power makes 49, doesn't it? So these would be the values for these logarithms, wouldn't they? So far, we're lucky. So far, these are nice, round, nice, easy, make a list, stumble upon the answer. That isn't always going to work, but so far, so good. All right, so log base 4 of 16,384. Equals what? Again, same question. 4 raised to what power equals 16,384? Well, making lists seems to work. Let's stick with that. You know? Okay, and I got to make room for later questions. I'm going to get these out of the way. But let's try the same approach. Okay, so you go, well, 4 to the first is 4. 4 to the second is 16. Notice these are very far short of the target. 4 to the third equals 64. Man, we're not even getting close. Let's say you got tired of this. Let's say, nah, I don't want to do that anymore. That's taking too long. We're not even getting close. Plus, there's no guarantee it'd be on the list anyway, right? So this would be, in my opinion, a good candidate for idea number 4, which is called change of base. And here's the deal. We mentioned earlier that calculators can do 2 types of logarithms. Those that have a base of 10, otherwise known as common logarithms, and those that have a base of e, otherwise known as natural logarithms. The problem is this example is base 4, and calculators don't have base 4 buttons, do they? Dang it. So, there's no button for log base 4. But what if we could change that into one of the two that the calculator could actually do? Wouldn't that be awesome? And nice, fortunately, there is a way to do that. That pattern right there, and I'm already discovering that I've painted myself in a corner, so I'm going to back this up a little bit, okay? Let me transfer this back this way a little bit here. Log base 4 of 16,384. I should have, it's hard here without much board space. But let me transfer this back up here real quickly. We got tired. We didn't want to keep the list, all right? Look, that pattern right there says, you know what you can do? You can take any old base, I don't care what it is, and change it into this pattern here. I like to point out that the base goes in the basement and the anti-log goes in the attic. So if you apply that pattern to this question, that would be the log of 16,384. But you know what? That's not any old log. That is a base 10 log. That is a common log. Both of these have been changed into common logarithms. The common logarithm of 16,384 over the common logarithm of 4. Those are ones where there's a button on a calculator. Cool. All right. So you can put them in a calculator now. And this is where it's difficult because, you know, we're sitting there far away from each other. But again, I hope you understand it's called change of base because we changed that question from base 4 into base 10. And base 10 is the type the machine can do. So here's what I recommend. Common log 16,384 button, right? And equal, and that's going to be some nasty old decimal. And then divided by the common log of 4. And if you do it correctly, the whole thing, when it's all said and done, should equal 7. And the point of this would be that if we hadn't run out of steam, when we got to 4 to the 7th power and put in our calculator, let's do it. 4 caret 7, just to confirm this, 16,384. 4 to the 7th power equals 16,384. Boom. Didn't have to make a list. Okay? Now, calculators can do common logarithms. That pattern suggests it's okay to do that. Also, it's allowable. If you want, I want you to see it's the same pattern, base in the basement, anti-log in the attic. If we had wanted to, we could have done natural log on both of those. And just to confirm that, and I know this is lazy, but board space is at a premium. But if we had wanted to, see, you leave the numbers in the same place. Base in the basement, anti-log in the attic. But if you'd wanted to push the LN button in both cases, still comes out the same. Common log, pardon me, natural log, ln, 16,384 equals, divided by natural log 4 equals 7. Same thing. All right? So pick your favorite button. It doesn't matter. It's the same pattern either way. So that's an extremely powerful thing, that change of base. And so let's see, I'm going to erase here to make some room for some more examples here. And I don't know if any of you would ever catch this, but ask your parents or grandparents. Change of base makes me think of an old band from the 90s called Ace of Base. I miss you guys so much in our math parties. Oh well, all right, let's get this other column out of the way. Now here's the deal, we just showed you how to do change of base. The problem that I've learned is when you show people change of base, they assume you use change of base the rest of your life. This next example, log, there's not a base there. I know. That's called a common logarithm. And that is the kind that the machine can do for us. We do not need change of base because that's common. It's base 10. That's a button. Hit the button that says log. Hit the button that says log 9742. Boom. Don't overthink it. I believe the instructions were 4 decimal places, so that'll be 3.9886. Boom. Button. LOG. No change of base required. It was common to begin with. All right. Don't overthink it.
That was easy.
That was easy. It was almost too easy. Next example. Natural log 387. Natural log 387. That's a button. That's a calculator function. There's no need for change of base. That's a natural log. I'm hitting that button that says ln and putting in 387. And according to my calculator, that's about 5.9584. Boom, done. Don't overthink it. Okay? So hopefully that makes sense. Last example on this slide. The log base 2 of 148. Now, you gotta go. You know what? Calculator doesn't have a log base 2 button. It's got a log base 10, otherwise known as common. It's got an ln, which is base e. That base is neither one of those. Yeah! I'm gonna do me some change of base. What do you think? All right? And again, it doesn't matter. I should put the word or in between here. But the main thing to keep in mind is that the base goes in the basement. Notice that the b goes on the bottom and the anti-log goes above. And then it's just a matter of which button do you feel like pushing. Natural, natural, common, common. I usually choose natural. Just sounds better. All natural, no preservatives. And so, look, I pull my calculator on the screen, but I'm sure it's very difficult to see there. So I'm going to go ln 148 equals divided by, I did hit equals in between. ln 148 equals divided by ln2 equals, and it looks like this is about 7.2095. Bang, 4 decimal places. So again, that was another situation where our good old friend change of base made sense. Change of base sounds a lot like ace of base, doesn't it? So let's leave with a little more ace of base. They're from the 90s. I think they were from Sweden. Here we go. I love this video. It's called It's a Beautiful Life. We have a lady here taking a nap in the afternoon in a sunlit room. And then, watch this. This is so cool. And then all of a sudden, people fly out of her mouth. Just love videos, cheesy old videos from the 90s and even before. It's a beautiful life. Oh, oh, oh.